What if you woke up one morning, looked to the horizon, and saw two suns rising together? One golden, one orange, painting the sky in colors we've never seen. It's not science fiction, it's real. Welcome to Alpha Centauri A and B, the star system right next to ours. Two brighter stars come into view. They shine with a steady, familiar warmth, not too different from our own sun. These are Alpha Centauri A and Alpha Centauri B, the second closest star system to Earth. Their light has traveled across the vast emptiness of space for over 4 years to reach us, crossing a distance so immense that it challenges our imagination. And yet, in the cosmic scale of things, they are practically our neighbors. Together with Proxima, these two stars form a triple star system known as Alpha Centauri. While Proxima is the closest to Earth, Alpha Centauri A and B are the most visible. In fact, if you live in the southern hemisphere and look up on a clear night, you've probably seen them already. They appear as a single bright point of light, one of the brightest stars in the night sky. To ancient civilizations who gazed upward, this brilliant beacon was a guide, a marker in the celestial sphere. What you're actually seeing are two stars so close together that your eyes can't tell them apart. But through a telescope, they separate into two golden lights, dancing around each other in slow, precise loops. It's a cosmic waltz that has been going on for billions of years. Astronomers have known about Alpha Centauri for a long time. It was first catalogued in 1603 by German astronomer Johann Bayer, who gave it the name Alpha Centauri because it was the brightest star in the constellation Centaurus. Bayer was creating his groundbreaking star atlas, Uranometria, which would become one of the most important astronomical works of the early modern era. For a long time, people believed it was just one star, a single point of light shining steadily in the southern sky. It was only when telescopes became powerful enough that scientists realized there was more to the story. What looked like one star to the naked eye turned out to be two. Two bright stars orbiting each other in a slow, graceful loop. These were eventually named Alpha Centauri A and Alpha Centauri B. The discovery that this single point of light was actually a binary system was revolutionary. Then came a surprise. In the early 20th century, astronomer Robert Innes discovered a third star nearby, Proxima Centauri, a faint red dwarf hiding in plain sight. Innes was working at the Union Observatory in Johannesburg, South Africa, when he made this discovery in 1915. It was dim and distant from the main pair, but moving in the same direction. Over time, scientists confirmed that Proxima was gravitationally bound to Alpha Centauri A and B, forming a triple star system. So what we once thought was a single light in the night sky was in fact 3 stars, a close-knit family quietly orbiting together across millions of years. This discovery fundamentally changed our understanding of our nearest stellar neighbors. Later in the 19th century, scientists like Thomas Henderson and Manuel John Johnson took the next step. They used a method called stellar parallax to measure how far away Alpha Centauri really was. As Earth moved around the Sun, Alpha Centauri appeared to shift slightly in position against the backdrop of more distant stars. It's similar to how your thumb appears to move when you close one eye and then the other. By measuring that tiny shift and knowing the size of Earth's orbit, they were able to calculate its distance. The measurements required extraordinary patience and precision. Their results revealed something astonishing. This bright star system wasn't just another light in the sky. It was our nearest stellar neighbor, sitting just 437 light-years away. This distance is almost incomprehensible in everyday terms. Light travels at 299.792 kilometers per second, and even at that incredible speed, it takes over 4 years to cross the gap between us and Alpha Centauri. With the system mapped, let's slow down now and meet the stars themselves. One by one, Alpha Centauri A is the larger of the two. It's about 10% more massive than our Sun and roughly 1.5 times as bright. Its surface temperature is around 5,800 degrees Celsius, just a bit hotter than the Sun. If you replaced our Sun with Alpha Centauri A, Earth would still be in the habitable zone, and life might continue much as it is now. Our seasons would be slightly warmer, our days a bit brighter. This star is classified as a G2 type star, just like the Sun. In other words, it's a yellow dwarf, middle-aged and stable. A star like this can live for billions of years, steadily fusing hydrogen into helium in its core. Our Sun is about 4.6 billion years old, and Alpha Centauri A is roughly the same age. Alpha Centauri B is smaller and cooler. It's about 90% the mass of the Sun and shines with about half the Sun's brightness. Its surface temperature is around 5,300 degrees Celsius, which gives it a more orange color compared to Alpha Centauri A's yellow-white glow. The difference in color is subtle but noticeable when observed through a telescope. This star is a K1 type star, known as an orange dwarf. These types of stars tend to be quieter and live even longer than stars like our Sun. They're less prone to violent solar flares and have more stable outputs of energy. The two stars orbit each other every 79.91 years. That means one full loop takes nearly 8 decades, almost a human lifetime. Their orbit isn't a perfect circle, it's more of an oval, or what scientists call an ellipse. At their closest, they're about 11 times farther apart than Earth is from the Sun. That's roughly the distance between the Sun and Saturn in our solar system. At their farthest, that stretches out to 35 times the Earth-Sun distance. Even at their closest, the stars are too far apart to tug on each other's planets in any serious way. This gives each one its own space to host a planetary system. And that's where things get really interesting. Both Alpha Centauri A and B have their own habitable zones, meaning there could potentially be Earth-like worlds orbiting either star. For decades, astronomers searched for planets around Alpha Centauri A and B. For a long time, they found nothing certain. It was frustrating. Here we have stars so close, so sun-like, and yet no planets we could confirm. The Alpha Centauri system has been one of the most intensely studied star systems in the entire sky. But in 2012, scientists from the European Southern Observatory announced they had detected a planet around Alpha Centauri B. They called it Alpha Centauri BB. It was believed to be a rocky world, perhaps Earth-sized, orbiting its star every 3.2 days, way too close for life. At that distance, the planet would be scorched by its star's radiation. Unfortunately, the signal was weak. Later reviews suggested it might have been a false positive caused by noise in the data. For now, that planet remains unconfirmed. Years later, in 2021, astronomers using a telescope called the Very Large Telescope in Chile discovered something else, a possible planet orbiting Alpha Centauri A. The planet wasn't seen directly, but hinted at through a method called infrared imaging, which looks for the faint warmth of a planet rather than the light it reflects. This object was detected about the same distance from Alpha Centauri A as Neptune is from our Sun. If confirmed, it would be a giant planet, maybe something like Saturn or Jupiter, orbiting quietly on the edge of its system. A planet like this could have its own system of moons, some of which might be large enough to have atmospheres. More discoveries might still be ahead. The Alpha Centauri system is now a top target for exoplanet hunters, especially those looking for Earth-like worlds. NASA's upcoming missions and telescopes, including the James Webb Space Telescope and others in development, may help us finally get a clearer look. New techniques are making it possible to block out the overwhelming light of stars and see the faint planets orbiting them. The system has also inspired dreams of interstellar missions. Before breakthrough starshot focused on Proxima, Alpha Centauri A and B were often mentioned as potential destinations. Various proposals have been put forward over the years. The proximity of Alpha Centauri makes it the most realistic target for humanity's first journey to another star system. You've probably heard the name before in films or books. Alpha Centauri is a favorite setting for alien civilizations, future space colonies, or interstellar missions gone wrong. It appears in Avatar: Mass Effect, Sid Meier's Alpha Centauri, and dozens of other works. That's no accident. It's the closest place that feels like it could be something like home. And if we ever did manage to stand on a planet in the Alpha Centauri system, the view of the sky would be unlike anything from Earth. From a planet orbiting Alpha Centauri A, you'd see Alpha Centauri B shining brightly nearby, far brighter than our moon. Depending on where the planet was in its orbit, the companion star might cast shadows and provide significant light. If the system has moons or rings, they'd be bathed in a golden-orange light. Proxima, though distant, would appear as a faint red dot in the background, still part of the family, just farther away. Alpha Centauri A and B show us what it looks like when stars share a space and still shine on their own. Two suns circling in the dark, whispering possibilities. For now, we listen, we watch, we imagine. But one day, we may finally know what worlds exist there.